We discussed about the work, the second chapter, but how to do the work easy way and more efficient, easy and fast. So how to do the work? Suppose if you want to do a work easy and fast, suppose to open a nut. Okay, to open a nut, it is not easy with the hand. If you take wrench, it is easy for you. Here we will use less. What is that? Less effort we will use. Less effort to open the nut. But whereas by hand it is difficult for you, you should apply more effort to make the work easy and fast. What we will use? Okay, not only this. Suppose if you want to pull a bucket from the well. Okay, what we will use? To make it easy, pulley. Suppose you want to lift a bucket from the well, this direction is very difficult. If you use pulley if you use pulley and bucket is tied for that, it is easy, convenient direction. Okay, by pulley. Suppose you want to move a stone, a big stone, with the help of a bar. Okay, I'll help with the help of a small stone. I'll move this stone towards that side. Okay, now how this is possible? These all, this screw, this bar, not only that, spade used to help turn the sand. These all are done easily with the help of which? Wrench is helping. Here bar is helping. You can say call it as a crowbar. Here pulley is helping to make our work easy. What these all are called as? What is this called? Machines. Okay. So now we are going to learn about the machines which we are helping. Okay, for us to make our work very easy and fast. Suppose example, if you want to lift heavy load with less effort. Example, we will take it as a, if you want to lift the car, to repair it tire. What if you want actually to lift the car? You will take jack. You will take a jack. What it will do? Okay, if you are going to rotate it, it will lift the car. But you are not lifting total car. But with a less effort, you are making the car to lift. So this heavy load is with less effort we are doing the work. So who is helping for us? Jack. This is called as a one machine. So we have talking about jack. So jack is lifting heavy load by using a less effort. We are seeing that jack to a wheelbarrow. You know wheelbarrow? Okay, this is a wheelbarrow where you used to lift it. In this we will keep load, and this wheel will be present here. So here it will be like this. You know that we use the dust to take the heavy load. They are going to use this wheelbarrow. These three machines, jack, pulley, wheelbarrow, will make our work easy by it will do our force. It will act as a force multiplier. What is this? Act as a force multiplier. This means we are using less force, but it will multiply our force and will make our work very easy. They are called as a force multiplier. They are helping in the force multiplier by using the less effort. This less effort is used by us to lift heavy loads. To lift heavy loads, you use less effort. This type of machines, what they are doing, it is multiplying our force. These are called as force multipliers. So example of that, jack, pulley, a wheelbarrow, etc. will have. You can take crowbar, you can take spade, we can take. All these are examples of the force multiplier. This is the first one. Force multiplier is the first one for us. Second one is a convenient point. Applying force at a convenient point. So this is the second one. Applying force at a convenient point where the effort is equal to the load. What is effort is equal to the load? Means by taking water from a well. This is the example for a convenient point. Now this will just So how much load is there, that much effort you have to keep it here to pull the bucket. Okay, but in this direction, if you want to lift the bucket, in this direction, load also in this direction, effort also in that, this is very difficult for us. Whereas if you go in this, with the help of pulley, if you are changing the direction in the convenient way, this will help load is equals to effort, but applying force at a convenient point make the work easy. Okay, not only this, for our toothed wheel we will have a cycle. The cycle backside will have a toothed wheel. The toothed wheel will be run by our pedals. That toothed wheel will make, it is attached to our rear wheel. Toothed wheel is attached to the rear wheel, and this makes the turn our wheel. So here this is, I am convenient point, I am applying the what? Force to move this wheel. So these type of examples are nothing but applying force at convenient point where the load is equals to the what? Effort. Here no gain in speed, or it will not multiply the force. How much you will pedal the cycle, that much it will move fast. So same as that, how much you are going to pull it down, how much your efforts you will do, that much load will be lifted up. This is the example of applying force at convenient point. First one is the force multiplier, second one is applying force at convenient point, and third one we will see now. Force multiplier, we have seen that jack and spade. Then so many examples we have seen for the force multiplier. Now applying effort in convenient direction, we have seen that pulley. Okay, example of applying effort in convenient direction is pulley. Change in the direction we will use. Okay, that is the second order lever, we can say it is a pulley. For the change, applying the effort in convenient direction, we can use pulley as example. Force multiplier is jack, spade, and we can say crowbar, etc. We can take it. Now gain in speed. So we have gain in speed by using here, by using the more effort, okay, we will get the gain in speed. Example of scissors. In the scissors, what happened? We will move that more effort will be more than your load in the scissors. So effort will be more than the load. This is the load we will apply here, the effort will be here. Okay, so effort will be more than the load. They will gain in the speed. Not only this, we can take it as a wheel and axles or toothed wheels also comes under gain in speed. So that is the third one, gain in speed. Second one is applying the effort in convenient direction. Force multiplier is nothing but jx speed, anything we can take. These are the example for that. So our machines can be act as a force multiplier. Machines can act like the applying the effort in convenient directions. Machine can act to gain in speed. These three are there, and individually how they are going to be played here. So actually machine, what is a machine? Machine is a device which can either overcome a large resistive force at some point by applying small force. That is nothing but a force multiplier at a convenient point and desired direction. I have said that we can use by using a machine we can change the direction of a force at a convenient point. Otherwise effort direction we can change it. And one more point is we can gain in speed with the help of machine. Three things it can do: force multiplier, change the direction, or convenient we can change the effort into the convenient direction. Okay, but we have the load and effort here. What is load actually? It is the resistivity. It is resistivity or opposing force. Opposing force should overcome by the machine. Overcome by the machine. So machine should overcome the load to do the work. Okay, what is effort? Machine should overcome means whatever the load we are keeping. In this example we are taking that suppose we are taking a clothes and keeping in a washing machine. So the load will become clothes, and effort is nothing but the current supply for that. So effort is nothing but a force applied or effort applied. You can take it as effort applied. Effort applied on the machine. What to do on the machine to overcome the load? To overcome the load. That is called as effort. So effort is nothing but a force applied on the machine to overcome the load. Then that is called effort. This is indicated as E, and this is indicated or denoted by L. So L, what is load? It is the resistivity or opposing force. Okay, it should overcome by the opposing force, overcome by the machine. Okay, that is called as a load. Effort is nothing but force applied on the machine to overcome the load. That is called as effort. So denoted by L, denoted by E. So we have the mechanical advantage. What is the mechanical advantage? It is the ratio of load to the effort. Load by effort. By taking this load by effort, okay, by this mechanical advantage, we will say that machine is a force multiplier, or it is change in direction, or it is a gain in speed by using the mechanical advantage. What is mechanical advantage? It is the ratio of load to the effort. Okay, mechanical advantage, load by effort, because I already said that what is the load and effort. Load is nothing but a resistive force opposing force, okay, overcome by the machine. What is effort? Effort is nothing force applied on the machine to overcome the load. That already we did, example also we give. Now load, suppose mechanical advantage, if effort is more than the load, then mechanical advantage, effort is more is, then mechanical advantage is less than 1. Then it will become, okay, gain in speed. Gain in speed. If effort is less, if effort less, I will write here, effort is less, then effort is less, mechanical advantage will become greater than 1, then it is called as a force multiplier. Force multiplier. So here mechanical advantage suppose equals to 1, that is load is equals to effort, it will become mechanical advantage is equals to 1. This is called as change in direction. Like this we can find out the machines. Okay, so mechanical greater than 1 means, suppose example, mechanical advantage is equals to 3 by 4. Your load is 3, effort is more, then it will become, so less than, this is 3 by 4 is less than 1, then therefore it is gain in speed. Like this, suppose mechanical advantage is equals to 4 by 3, this is greater than 1, okay, therefore it will become force multiplier. So if the answer is 1, then that is become change in direction. We can identify like this, mechanical advantage is nothing but it is a load ratio of the load to the effort. Now velocity ratio. So velocity ratio is also ratio to the velocity of effort to the velocity of load. Now we know that velocity is nothing but a distance of effort by time. So distance by time. Here also velocity is nothing but distance by of the load by time. We can write like this, distance of effort by distance of load is nothing but velocity ratio. If same velocity ratio, suppose load is greater than effort, what happens? So velocity ratio will become less than 1. If it is less than 1, what happens? It is gain in speed. Gain in speed. Velocity ratio is greater than 1, force multiplier. Velocity ratio is equals to 1, then it is change in direction. Both we can use it, velocity ratio as well as mechanical, both we can use to find out where is the force multiplier, gain in speed or change in the direction. But here we will use distance of the effort, distance of the load. Here directly we will use load and effort. Okay, if you don't have load, they have given the distance of a load and distance of effort, we will use the velocity ratio and we are going to find out whether it is a force multiplier or gain in speed or change in the direction. So what is the distance of effort, distance of the load? Suppose this is the fixed point, we are going to keep a load in this. Okay, you are applying a force here. That means effort here. Okay, this is called as the distance of the load, and this is called the distance of the effort. By using this distance of the load, distance of the velocity ratio, we can find out, and we can say that it is a force multiplier, gain in speed or change in direction. So in this way we can say. So we have work input and work output.